All right, so the thing I wanted to talk about, which you segued so perfectly, is Mount Washington Observatory.
Oh man.
All right, we should be able to just let this rip. Okay,
That's just a wild video. It doesn't even look like
it's
Earth.
it doesn't. It looks like okay. It's kind of cringe, but one of the reports I heard was like, it looks like Hoth from the Star Wars. It's like cringe, but true. Like, look at that. Okay,
It's awesome.
negative 104 wind chill.
That's just unfathomable.
That's just
For
I
a
can't.
southern boys like us, we don't fare well in that.
I think they're. Yeah, so, and one of the interesting things about that was, I guess, technically above the Tropopause.
It was, and I've seen some arguments that say, "Oh, it couldn't have possibly been. The tropopause wasn't that low." Even if it's just a tropopause fold, that's still pretty impressive.
Well, I think it counts
It,
because
it counts. It absolutely counts.
I,
I saw the
it's
argument was there wasn't an increase, like a massive increase in ozone. And
mhm.
for those who don't know, typically the gas ozone, which protects us from UV radiation, is trapped in the stratosphere. That's where it likes to hang out. And so typically if you get above the tropopause into the stratosphere, you'll see an increase in that. But I still think this absolutely counts.
Well, and that's why that you were talking about the temperature inversion when you get to the stratosphere. That's why that temperature inversion is there, is because of the ozone. So yeah, so the arguments I've heard was that there wasn't enough ozone, and the other argument was mostly just along the lines of like, okay, we don't have an actual hard stop definition of the tropopause, and because we've basically defined the tropopause as, or we've basically defined the troposphere as everything, everywhere, all the weather happens in the troposphere. The fact that this is going on means that can't technically. It's a weird definitional thing. I don't think that's fair.
Yeah, I mean, if you look at soundings from Mount Washington on that day, it's pretty clear the tropopause
Yeah,
was incredibly low.
yeah. Well, okay.
I mean,
Let me
it's
find a
only
sounding, and you explain why a
yeah.
tropopause can be high or low.
Really reaching into the bag of weather knowledge now. But typically, what'll happen is in warmer temperatures, that the tropopause will tend to be deeper. So, right, you can think of it very simply as the warmer a gas is, right, the more it expands. And the same thing happens in the troposphere, right? When air is warmer, for the most part, you tend to get higher tropopause values. So in severe weather, the reason you can get deeper convection, taller thunderstorms in warmer temperatures is because of that idea. And in super cold setups, that tropopause can shrink all the way down. And I think here it was only a kilometer or so off the ground. It was something incredibly low like that, which the peak of Mount Washington, which is the reason why we think it was in the stratosphere, whether it actually was or not, the peak of Mount Washington is above a kilometer above the ground. Now, how deep actually is the tropopause or that interchange zone? There's a lot of debate to that. It varies. Um, but in this setup, it was extremely cold, as Colin mentioned. Wind chills are pushing negative 100, which is incredible to me. I can't even imagine something that cold. I imagine once you get past a certain like number, it all just feels the same. Like, how could it possibly feel any colder? Well, I guess it's the same thing with heat. It can't possibly get any hotter after a certain point. So, but yeah, it that's the simplistic way to look at it. There's a lot of extra dynamics on top of that can factor into just exactly how tall or short it ends up getting. But there, like I mentioned, we have some very long equations to to describe
no,
that.
we don't. No, we don't. I don't remember them. Don't remind me. I'm trying
Spend
to.
one podcast just reading the dynamics textbooks.
You're doing that.
It's
You're
not a
doing
fun
that
read.
one on your own.
It's
You are
not a
doing
fun
that
read,
one
folks.
on your own.
People tend to get into the field of meteorology, and rightfully so. They see, everything that happens on TV and whatnot, and think that it's as simple as, you look at what the models are saying, and you make your forecast off of that. You can do it that way, but to be a really good forecaster, you have to understand how all of these things connect and these equations and the math that goes into it. It's hardcore math in meteorology. And I don't want to say that and scare anybody thinking about going into the field of meteorology, saying, oh, if you can't do math, you can't do it. That's not true. There are ways to improve upon the mathematics that go into it. It can be scary to look at it at first. You see equations that are lines and lines long. But this is meteorology. We find ways to simplify down these equations as much as possible. There's a lot of terms that'll end up canceling out. The one thing I will say, you have to be very good at differentiation and integration. Again, I don't mean to say that to scare anyone. I know for a lot of people, math can be very intimidating if you're not good at it. But if you work at it, it is something that will be overcome. Any meteorologist who has a meteorology degree has been through it and been able to do that. And so, with maybe some help from some friends or some dedication to improving at that craft, it can be done. I wouldn't be sitting here, Colin wouldn't be sitting here if it wasn't possible.
Yes, because I am bad at math. I hate math. I never want to do math again in my life, and I made it. So
man.
it's...
We had to take how many math courses at OU? It was...
Too many. Too many.
Took Calc 1, Calc 2, Calc 3, and then you take physical mathematics, which is
Awful.
It's not the most fun class. Imagine taking everything you hate about trigonometry and calculus and combining it. It's not fun. It's you have to have a very imaginative mind to really be able to fully grasp some of the concepts in that class. But what you learn from it goes a long, long way into helping with this stuff for sure. Stats is a huge part as well. Luckily, a lot of people have calculators now that can do all those statistics for them, which is quite nice.
Okay. I think this is the correct sounding.
Okay.
I'm not entirely sure. I would guess, considering this is, well, yeah.
That's pretty close, yeah.
So that's
I mean,
that one.
So yeah, I'll let Colin look over this.
Well, surface temperature -13, surface dew point -31.
And that's in Celsius. Folks,
yes,
so.
that's in Celsius, granted, but so typically, actually, let me just pull up like another. Let's just pull up Amarillo for that same time. So we. What? Okay. I really don't want to. Can I not? Okay, I can't. That's dumb. Anyway, so if you kind of note, everything deep.
It was dry in Amarillo. Holy cow!
Well, when is it not? It's like, so everything temperature-wise decreases with height until you get to a certain point and then begins to increase. That's where, like you mentioned, you pick up all that ozone and you start having that temperature inversion. So look at where the temperature inversion is here. Like,
oh man, that is super, super low.
That
might be the
intense.
lowest tropopause I can remember seeing on a sounding.